Welcome back to another lecture on OpenDSS G. I'm Davis Montenegro, the creator of the tool. Today, I want to give you a quick, friendly tour of what's new in OpenDSS G version 7. This release is the result of years of experimenting with better ways to interact with OpenDSS graphically and to showcase both its core features and its more advanced capabilities. To support that, we've upgraded the entire graphical environment with a more flexible, fully vectorized framework. You'll notice the difference right away. Zooming in and out feels effortless, and the interface stays crisp at any scale. You can also adjust the schematic on the fly, flipping it vertically or horizontally with a single click. So the workspace adapts to whatever view makes the most sense of your model. The mini viewer has gotten a nice upgrade too. It is still the tool that helps you keep your bearings when you're zoomed in on the schematic, but in version 7, it is much more flexible. You can resize it to whatever feels comfortable, and it now tracks your position in real time as you move around the circuit. It also highlights the locations of all voltage sources across the model, which makes it easier to reference key points without hunting through the schematic. And just like the main view, the mini viewer automatically flips whenever you flip the schematic, so your orientation always stays consistent. These visual improvements are only part of what's new. Version 7 also introduces several new features designed to speed up your simulation workflow and make the whole process feel more fluid. In version 7, OpenDSS G now creates buses automatically as soon as you declare an element. This brings the graphical workflow much closer to the original OpenDSS scripting experience and makes building circuits visually a lot faster and more intuitive. It also makes starting from scratch in the scripting tool feel familiar if you're used to the OpenDSS executable. You still get the same scripting style, but now with helpful additions like autocomplete, support for large scripts, search and replace, and the ability to toggle line comments with a click. It is a much smoother environment overall and definitely worth exploring. OpenDSS G can now suggest a topology directly from your circuit description. This used to be something you only got when importing full DSS models, but in version 7, you can use it at any time, whether you're building a new circuit or just trying to clean up how your elements are arranged on the screen. It is especially handy when you want a layout that reflects the circuit's actual connectivity and line lengths, giving you a consistent, meaningful topology with almost no effort. Graphical reports like the voltage profile graph have gotten a big upgrade as well. The graph is now fully interactive, so you can click on a point and immediately see how that measurement ties back to the circuit in the GUI. It creates a much tighter connection between the data you're looking at and the physical layout of the model. You can also manage zones directly from the graph and split measurement areas in real time. This is useful not only for the analysis but also for teaching, explaining concepts, or walking someone through the logic behind your simulation results. It turns the graph into more than just a plot. It becomes a visual workspace for communicating ideas and exploring system behavior. Numerical reports have gotten a solid upgrade too. You can now tailor them using simple conditionals and choose exactly what information appears in the output. The reporting tool essentially works like a lightweight assistant sitting on top of a NoSQL-style database, letting you query the values you care about whenever you need them. Once you've generated the report, you can export the result to tools like Microsoft Excel, or just copy them to the clipboard and paste them whenever you're working. The goal is to give users a straightforward way to pull data out of their simulations, something that complements the graphical insights while giving you full control over the numbers behind them. The Circuit Navigator has also seen a meaningful upgrade. It now works as a full circuit editor built around an on-demand tree structure, making it much easier to explore your model as it grows. The tree stays closely linked to the GUI, so selecting an element in the navigator highlights it on the schematic, and you can edit properties right there without breaking your flow. It adds a smoother, more flexible way to move through and refine your circuit inside the graphical environment. The navigator also expands its export options. In addition to Excel and clipboard export, it now supports JSON, which makes it much easier to move model information into other simulators or programming languages. It is a small addition with a big impact if you're integrating OpenDSS G into a broader workflow. Version 7 also brings in the load allocation assistant. a straightforward graphical interface that makes it much easier to work with OpenDSS load allocation features. You can import measurement data, edit existing values, and add new ones directly through the interface without jumping back and forth between tools. Once you're done, the results can be exported for later use, which helps demystify the load allocation process and makes this part of OpenDSS much more approachable. Finally, we want to hear from both users and developers about where the software is today and where it should go next. You can share your thoughts through the SourceForge forum or head over to opendsssg.prodcam.com to vote on upcoming features, suggest new ideas, or even join us in the development effort. Bringing everyone together around this open source project helps us keep pushing the boundaries of what modern electric power simulation tools can do, both now and in the future. And that brings us to the end of this quick introduction to OpenDSS G version 7. I hope the walkthrough gave you a clear sense of what's new and how these updates can support your work. Thanks for joining me, and I'm looking forward to having you back in the next lecture.